Hello, grade 8. So this week we are continuing with chapter 2, mechanical action and forces, and we are actually finishing this chapter. All right, so let's start. So these are the objectives that we're going to cover. Now I know we already talked about the types of forces before and three contact forces, so I will be moving on those pretty quick, okay? Then moving on to the rest. So we said we have two types of forces, the contact forces and the forces acting from a distance. The contact forces, from the name of it, it means that it is the force that happens, that appears due to the contact between the two bodies. Whereas the force acting at a distance, it means that there is a force that is happening between two bodies, but these two bodies are not in contact, so they are not touching each other. So the first contact force is the tension force, T. The tension force, T, is the force that is exerted by a spring, by a string, by a thread, all right? So we will talk about the string case first. You can see here we have two solids or objects hanging from a string. And for me to actually represent this tension force, I need to know its characteristics. So the point of application is always the point of attachment. Where is this object attached to this string? All right, so where do they touch at this point? The line of action is always along the string. So it depends if the string is vertical, if it's oblique, if it's horizontal. It is always along the string, and the direction is always inside, towards the inside of the string, like trying to pull up, trying to pull towards the string, all right? Now the case of a spring, in case I have an elongated spring, you can see how elongated it is. It is the same case as a string. The point of application is the point of contact or the point of attachment, line of action along the spring, and the direction towards the inside of the spring. All right? Now the case of a compressed spring, this is different. The point of application is still this point. The line of action is still along the spring, but the direction now, it would be towards the outside of the spring and not the inside, because if you are actually doing this, you would feel that there is a force pushing your hand, let's say outwards, all right? So this is the difference between a compressed spring and an elongated one. And the second contact force is the normal reaction, N. So it is the force that is exerted by the support on the body that is resting on it. Now this support, it could be a table, floor, wall, or inclined plane. We can see here three different cases. All right, so three different cases. So in the first case, we can see that this ball is resting on this wall. So I have a normal reaction, which is perpendicular to the support. And in the second case, we can see that this box is resting on this inclined plane. So we have a normal reaction, which is perpendicular to the support. And the last one, we have this, the cup of coffee sitting on a table. So I have a normal reaction, which is perpendicular to the support. So let's get to know the characteristics of this normal reaction. As for the point of application, as we can see, it is the point of contact. It is a contact force. So it is the point of contact between the support and the body that is resting on it. So where do they touch? They touch at this surface. But I can't just choose all the surface. I have to choose a point. So I choose the center of the contact area, okay? Which is like this point right here. All right, it's this point. Now, as for the line of action, it is always perpendicular to the support. Whatever the support is like, the line of action, the normal reaction is always perpendicular to the support. You can see that. All right. And for the direction, it is always from the support towards the body. So from the support towards the body, just like that. All right. And the third contact force is the muscular force, which is the force that results due to the action of muscles. I'm not going to write the characteristics of such force because it depends on how am I actually doing the force, all right? So just know that muscular force, it is due to the action of muscles. And the last contact force we're going to talk about is the friction force, F. Friction force, from the name of it, friction. It is created when two bodies move across each other. Okay, friction is like rub your hands together. Do they get warm? Yes, this is because of friction. So this is friction. It's like when two bodies just move across each other. Okay, now we're gonna learn about this type of contact forces using this simulation in the next slide. Okay, so when you go to the link, this will open up. You go to friction, all right, and you press on it. Great. So now the first thing that I'm going to do is that you see the friction here? Okay, so I'm gonna put it at lots. It means that I have lots of friction on this road. It's actually like the road is rough now. It's not smooth. It's rough. When the road or the surface is rough, it means that we have lots of friction. Okay, I'm gonna just let this man try to push this box. You see, I was trying too hard in order for him to push the box because the surface is rough. Now you can see the applied force is to the right, but the friction force is to the left. So the motion is to the right, but the force of friction is opposite to that of the motion. It's like a force that is trying to stop the motion, you know, something like that. Okay. All right, so we saw that. What do you notice? What can you say like about the line of action and the direction of this force? Okay, we can say that the friction force is in the same line of action as the motion. Okay, it is horizontal, but it is of opposite directions. It's going to in an opposite direction of the motion. Now, what if I put the surface smooth now? All right, and let this man just simply push this box. Do we see any friction force here? No, there is no friction force. And why is that? Because the surface is smooth. It means that the friction force is negligible. It's almost zero. So we don't consider it. So when the surface is rough, we have a certain friction force. When the surface is smooth, we don't have a friction force. So we saw in the simulation before that a friction force occurs when two bodies are simply moving across each other, when they are like rubbed across each other. Okay, and yeah, so let's talk about the cases we have here. This is the first case and the second case. The first case, we can see that there is a box that is sliding down this inclined plane. The second case, the box is moving to the right. All right. So, how can I actually represent this friction force? I need to find the characteristics of it. So, starting with the characteristics of a friction force. First of all, it is a contact force. Contact force, it means that the point of application is the point of contact. Great. So, what is the point of contact between the box and the plane? It is this point right here. Okay, it is the red point right here. This is the point of contact. Great. So it is the center of the contact area between the support and the body. All right, same point as that of the normal reaction. All right. Now how about the line of action? The line of action, we saw it in the simulation. It is along the motion, but it has opposite direction. So it goes the other way. This is the friction force along the motion, but opposite to the motion. All right. How about the magnitude? I'm not going to talk values here, but I'm going to say that if I have a rough surface, then friction exists. It means that we have friction. But if we have a smooth surface, it means that the friction is negligible. All right? So you guys be careful on a question. If I said that the surface is smooth, then you don't consider friction. But if I said that the surface is rough, it means that friction actually exists. All right. So the four contact forces that we talked about are the tension force, the normal reaction, the muscular force, and the friction force. All right. Now moving on to the forces acting at a distance. Now moving on to the last part of the chapter, talking about the forces acting from a distance. Okay, so the forces here are no longer in contact. So we talked about contact forces such as tension, normal reaction, what else? Muscular and friction. Okay, now we have the forces acting from a distance. We have weight, we have magnetic force, and we have electric force. So we're going to talk about each of these. Weight. When we talk about force acting from a distance, what is the first thing that comes to your mind? Maybe if you just simply let go of your phone right now, it will fall to the ground. Don't do that, but if you did, it will do. Why is that? Because there is some kind of force, right? Exerted, or a force of attraction exerted by the earth on the body that you're holding. So something is pulling it down, something is pulling this body down to the ground. But is there a contact between the ground and this object? No, there wasn't, okay? So what is the point of application in this case? The point of application in this case is the center of gravity. You see in these three pictures, okay, this first one, the second one, and the third one, the center of gravity, it's this point, okay? It is the point where the force acting from a distance is applied, okay? All forces acting from a distance, they have this same point of application because they are not in contact with the body, so the force is applied or exerted, okay, at the center of gravity of the body. Now, talking about weight, weight is always vertical. Its line of action is always vertical. It doesn't matter how the surface is. It doesn't matter how the support is, okay? Unlike normal reaction, which is perpendicular to the support. In case of weight, it's always vertical downwards. In all cases, it's pushing the object down, vertical downwards, all the cases. So if I want to write the characteristics of the weight, I would say that the point of application is the center of gravity, and the line of action is always vertical. You can memorize these, and the direction is always downwards, okay? So it's really an important force. Moving on to the second one, which is the magnetic force. From its name, magnetic, so it has something to do with a magnet. You know how a magnet attracts, let's say, an iron object? Yes, we've seen it before, and we've definitely tried it before. So this magnet is not in contact with this iron ball, but yet it's applying or exerting a certain force on this ball. Okay, so this force, we call it magnetic force because it has something to do with the magnet. Now its point of application is the center of gravity. And why is that? Because it's not in contact with the ball, so it is a force acting from a distance, so its point of application is the center of gravity. Magnetic force is a force of attraction that occurs between a magnet and an iron ball in this case. Okay, so how do we draw it? How do we draw it? If this is the point of application, it is attracted to this magnet, so it's as if someone is actually just pushing it that way, right? So this is the magnetic force. The characteristics, we can say that the point of application is the center of gravity. The line of action, I don't know the line of action. It depends. Now, in this case, it is horizontal, but the magnet could be here maybe next time. Okay, then it could be vertical. So I can't actually just give a generalization for the line of action. It depends on each case. So you guys, you don't need to actually memorize them. It's more like to understand what's going on. Okay, but the direction, it's always towards the magnet. So it always goes towards the magnet. Okay. Just like in this case, it goes towards the magnet. And the last force acting at a distance is the electric force. Um, when I say electric force, I'm talking about like static electricity. I know you are not familiar with that yet, but it's the case where you rub a balloon on your head, okay, and then you watch as you pull the balloon away, you watch your hair just kind of stick to the balloon, okay, and your hair simply goes up. So there is some kind of force exerted here exerted from the balloon on your hair. Okay, this is the electric force that I'm talking about. So it is exerted between any two charged bodies. Now, when we say charged bodies, they could be positively charged or negatively charged. So these are the two charges that we should be familiar with, positively or negatively. Its point of application is the center of gravity, of course, because it's a force acting at a distance. We have three cases. All you need to know is that opposite sign charges attract each other. Okay, so in case that the object is negatively charged and the body that is applying a force on the object is positively, it means that the sphere right here, the sphere will get attracted. See, it will go towards this object because they are oppositely charged. Okay, in case they have the same charge, both negative or both positive, they will repel each other. So the ball or the sphere will get away from these charged bodies because same charges repel each other, but opposite sign charges attract each other. Okay, I'm not gonna go into details with these. Just have a general idea about whether it attracts or whether they repel each other, because we're gonna need it later in an exercise. So same sign charges repel each other, whether both are positive or both are negative, they repel, they get away from each other. See how the ball is getting away and not towards the body? But in case of opposite sign charges, then it will get attracted. So the forces acting from a distance that we got to know, the first one is the weight. All right, so it is always vertical, downward, and it's always there. Like in every case, you have weight. All right, so you're gonna see it in every exercise. The second one is the magnetic force. It happens due to the presence of the magnet. All right, so you can see the iron ball getting attracted by the magnet. And the third one is the electric force. Electric force when the two objects are actually charged, so they have a certain sign. Opposite sign charges, they attract each other. So plus and minus, they attract each other. Whereas same sign charges repel each other. So if both of them are negative, they will repel each other. If both of them are positive, they will also repel each other. So we are done with the whole chapter. I hope you guys found it interesting. And in our live session, I will go over these, but in a faster pace because I want to solve a few exercises based on them. And you will understand them way more when we actually solve the exercises, okay? So I'll see you in the live session. Take care and bye-bye.